quick explanation of how to find uh, segment lengths from two secants and secant and a chord. Uh, Two secants would look something like this picture right here. Now we're going to add some extra dashes to help explain this on why this happens. So first thing you're going to do is I'm going to see this right here connecting from the circle to the circle intersection, and then I'm going to finish that part off, and guess what I find? A triangle. And the lengths of those sides, according to this diagram, are going to be A plus B, and this side down here is C. Now, I'm also going to go from intersection of the circle to the intersection of the circle and finish off that right there. And guess what that is? That's another triangle. And if I put those side lengths on, that's D plus C, and this is A right here. Well, both of those, they share the same angles. Okay, right here. Oh, that's the reflexive property. Nice. And then you could also see that they're both inscribed, and those inscribed angles are right there and right there. And what I've just created are, anyone? Yeah, those are similar triangles. So let me do this. So if I have similar triangles, then I can do something like, well, let's compare some sides. So if I take D plus C, that compares to A plus B. And then I have, if I go back to this triangle here, the red triangle, I have side A that compares to side C. Well, if I cross multiply, I have C times D plus C equals A times A plus B. This is actually the formula. I knew you were thinking this all along. This is actually the formula for two secants intersecting. So I have the outer of secant 1 times the entire secant, and then the outer of secant 2 times the entire secant. Okay, so it's outer times the entire equals the outer times the entire. Okay, that's a good formula to remember. All right, now what if I have a secant and a tangent? And again, I'm going to break this into different parts and use this diagram here. And that you're going to say, whoa, where'd that diagram come from? Well, what if I do intersection and combine? And so then I take that and it creates that triangle here, and I'll call that here's C and here's A. Okay, and then what if I take this triangle right here and I section that off? Well, that's going to be A plus B, and that is C right there. Okay, well, the reflexive property happens right here at P. Okay, and then from the last section, you know that this inscribed angle right here is the same as this angle right here. So that means this angle is the same as this angle. So now if I compare some sides, just like I did before, because now I have these similar triangles, so I'm going to compare sides. So I have A plus B compares to, watch where so I have the double marking in the single and the double marking in the single. So A plus B compares to C. And then I have the single marking to no marking right here. So I have to start with the green one again. So it's going to be C compares to A. And now if I cross multiply A times A plus B, that equals C times C. So A times A plus B must equal C squared. And that is the secant and the tangent. So it's the outer times the entire. I've heard that before. That's the secant part. And now, because there's no outer and entire, now I just take the entire times itself. Those are the two formulas you need to know in this section. Try some problems with them. They're not as complicated as you think. You gotta try them though. All right. Have a great day. Thanks for sticking with me here. Okay. Have a good day.